let's look at the first pattern, which will be escrow engine. As you know, an escrow pattern is just a situation where funds are temporarily held, maybe by third party service like PayPal used in Web2, until predefined conditions are met, just like you done in freelancing sites like Upwork. So the client sends the payment, it's held in a third party service till the client approves, and then till the work is over, then it's paid to the worker. But in Solana, the way it's done is that the funds are held in a program derived address, a PDA, and the PDA is sent to a vault before, and that is where the funds are held till the condition is met before it is sent to the other account. So if I should show you here, you can see that we've deployed it to DevNet already. You can check the program link. Like I mentioned, it relies on a third-party service to hold funds out to disputes, but in Solana it is replaced by a PDA to create a vault, then sent. It is controlled solely by the program's logic instead of the private key. So it's the program that determines this creation of vault and PDAs. Then it is kept in a vault. So as you can see here, the maker, who is maybe the client in this case, creates the escrow. The escrow program initializes. The escrow PDA is created. Then it is sent to a vault. Then from the vault, maybe the condition is met. So the tokens, the permission for that vault is now sent to the taker, exchanged to the taker. Then the escrow program now takes it and releases it to the taker as well, then closes the account, as you see in this visual diagram. So some of the constraints are that all subcomponents, that's deposit, transfer, and closure, must occur within an atomic transaction. So if any of these fails, it means everything will revert back to its normal state, unlike Web2 systems where you could do it partially, but Solana everything has to happen, which sometimes might be bad or might be good. It's controlled by a PDA, so since it lacks a private key, meaning only the specific program that owns the PDA can sign for it, making the code the legal custodian of the asset. So although this is rare, in a situation whereby you create an escrow for a period of time and something happens to that program on DevNet, maybe it's deleted, it means the transaction or the permission to release it to the other side does not exist anymore. Participant has pre-existing associated token accounts here. All that there must be funds in the wallet already necessary to validate this instruction, meaning there must be like a form of gas fee because you must sign it to validate this, which sometimes if you don't have the amount, meaning you must have more than the normal amount you want to keep in the Escrow to create this, which sometimes isn't nice, especially for maybe small businesses. But the trade-offs is this is a trust model. You are unlike the Web2 standard that is held by another agency. That agency could fall every day. This is held on Web3 on chain by immutable code, hereby nothing could happen to it except the program itself fails, like the server itself fails, which is extremely rare. Atomic settlement, meaning it happens almost instantly. Sometimes in Web2 you could require manual verification, but here it happens instantly. But if any step fails within it, like it fails. But this all or nothing execution kind of strategy is also very nice. The costs and fees, because sometimes the percentage fees taken from escrows sometimes in Web2 businesses, most Web2 businesses are higher compared to the ones taken on Solana. So yeah, but the only difference is that on Web2 you might not have the percentage immediately, but Solana you must have it to create the escrow. And these are example codes. As you can see, I created example codes for each languages in Node.js, Python, Flash, Java, CNet, and Go. So if you're a developer in any of this, you can read the code and try to understand what I'm trying to say, then map it so you can understand what exactly I'm talking about. Then you can map it to Web3, where you have your anchor. In this anchor, the full environment is in here, just the lib.rs and cargo HTML containing the dependencies. But in that case, it's not really like necessary, in the sense that once you run anchor in it, as you know, in the anchor docs, you should already be some sort of experience with anchor. Then you know that you just need this and this and to implement. Then and also you can look at it in native Rust if that's your type. If you prefer writing native Rust, this is the code for native Rust. So any way you want to transition into, this site has it for you. So let's do the test and interaction. Right, so let's go look at the test and interact. Keep in mind that you must connect your wallet here, but your wallet must have testnet so to run this test. That's the issue with Solana, but in exchange you are getting for sure execution and very fast speed. So you just need devnet. So if you don't know how to get devnet, so you can just go to the official website or request from here. But I already have devnet, so these two steps are filled in. Then for this, we are using the general monk mint address from the SPL token site. Now this ID is just to differentiate between different escrows they are creating. So this is escrow 1. Then let's say you haven't finished the first escrow and you want to put another escrow, so this will be escrow 2 in this case. But you can put any number for now, so just to differentiate, so like you can create multiple escrows. That's just the part about it in the code. So now let's create the escrow. This is from the maker side. Let's say it's creating the escrow. Now with the client is making the payment, so you must sign off on the payment. So as you can see, the escrow has been initialized successfully. This escrow has been created. You can check it out on the Explorer to verify that it has been created, but it hasn't been finished yet. And if you check on the Explorer, you notice. Now remember on the taker side, so this will be like the predefined condition met, which is for the taker to finalize the atomic swap in this case, but the predefined condition could be anything else. So now the taker finalizes the atomic swap. Obviously he signs off with some but if you notice, in this case now the wallet balance has gone down because it has been sent. We're doing it within the wallet. For this case, in this scenario, we're doing it within the wallet. So now some funds have been transferred to the PDA for holding, so it's in the PDA now. The wallet balance has been raised. The wallet balance went down. If you notice, it was 2.394, now it's 2.391. So those are the funds that went to the PDA. And now once the taker finalizes this, the atomic swap will be complete and the funds have returned, as you notice, because we did this within this wallet. But in another case, we can do it from wallet to another wallet. In this case, just to show that it worked. So that's all for the escrow engine pattern.